All right, we're going to continue to collect some more math XP by doing all of the following to these quadratics. We will be using the same skills from the previous video, but we want to emphasize more on what's convenient from these forms of quadratic equations. Mainly, we will do that by focusing on letter A, X and Y-intercept. And here's the key question. What's more convenient to find or easy to find in this form of quadratic? Is it the X or the Y-intercept? I will be asking that question for all 6. So let's get started. And in this format, I recognize that as the easiest thing to find is the X-intercept, all right? So let's begin with letter A, X-intercepts when X equals 0. And I will try to show fewer steps from the previous time. And we know that that happens when Y equals 0, all right? So when Y equals 0, these two are very easy to solve. We know that X equals either a -2 or a +10. So I'm gonna write them in X and Y format. -2, 0 is one of them. And the other one is 10, 0. So like I said, it's very convenient to find those in this form. And what's a little bit more difficult, but not that hard, is the Y-intercept. What do we know about Y-intercepts? It is that X equals 0. So we will get that Y equals, I'm going to show a little bit of step in this time. The next few I'm going to do in my head. When we plug in a 0 to this expression, we get a 2. What do we get when we plug in a 0 here? A -10. So that you can think of what we'll be doing in the next few problems. So really the Y value is -20, but let's write it as a point. X was 0 and the Y value is -20. So right away, we have 3 points to label on our graph, and we can start seeing the picture here. So -2, 0, I will plot somewhere right here, and then 10, 0, somewhere right there. See if you can sketch this ahead of time, ahead of me. All right. And then one thing that we know is that these parabolas have symmetry. So once we have the X-intercepts plotted, because they're points of symmetry to each other, line of symmetry will be somewhere right there. And we will find that by taking the average, finding the midpoint of those two X-intercepts. And that line is X equals some positive number. Let's find out what it is. 10 minus 2 is 8. Divided by 2 is 4. So X equals 4 is where the line of symmetry is located. There's 6 units to the right of here, 6 units to the left. Excellent. And we also have a Y-intercept of -20. Y-intercept of -20. And maybe at this point, it's a good idea to start connecting those dots. I almost did it all in one shot. It's okay. We will all get better as we do more of these. There we go. That's a pretty nice representation of what's going on with this quadratic. And we also know this point is 0, -20. Point of symmetry, remember that I won't be drawing on many more, but there's 4 units of distance here. Therefore, there's 4 here. That should be an 8 twice in the positive direction. And the Y value matches. It's 8, -20. And the last thing where I would probably show the most work on all of these is finding the vertex. Where is the vertex located? Vertex in this case is when X equals -4. Remember that for each quadratic, the X value of the vertex changes. So all I'm going to do now is take this 4 and substitute it into the factored form, which was given. So Y equals, when I plug in a 4 to the first expression, we get a 6. And when we plug in a 4 to the second expression, we get a -6. Therefore, the point should be 4, -36. And we are done with that one. All right, but remember the convenient form for this was to find the X-intercepts. Or the convenient form, think of a name when I say that. What would be a convenient name for this form? All right, and let's check another one. Let's do something similar. What do you recognize number 2 as? The first one I recognized that as something times something. So it was the X-intercepts that we're going to find. The next one is negative something times something. Therefore, the negative doesn't make it any difficult, but the X-intercepts, again, will be the easier thing to find here. So again, letter A, I'm going to start with X-intercepts. And we know that that's when Y equals 0. And because it's what I like to think a convenient for X-intercepts, I'm just going to go ahead and write the answer. One of the X-intercepts is 1, 0, and the other one is -7, 0. And hopefully you feel comfortable enough doing that in your own practice, where you can go from the equation straight to the answer. This is what I would claim as showing my work, showing my thought process that y = 0 is how I got these two values, or these 2 points on the graph. And the one that's not as convenient, but not so difficult to find, is y-intercept. All right, it's a little bit more work that we have to do. I'm going to do it in my head anyway. And that's when x = 0. When x = 0, we get a negative, I guess I will write it down, y = -1 times -1, so be careful, times when x = 0 is a 7. So this turns out to be, in whatever order you do it, it should be a +7. So the point is 0, 7. So by showing a little bit more work, it's not that much. We're still getting to the y-intercept pretty quickly. All right, that's letter A. And I always like to, once I have those 3 points, go to the picture. And I know that this will be something like 1, 0 right there. 7 in the negative direction will be somewhere right there. And we know that right in the middle of those two is the line of symmetry, since those x-intercepts are points of symmetry to each other. And this must be the 1, 0 on the right. On the left side, we must have the -7, 0. And next thing that we know is be careful with that negative sign. That tells you something about the quadratic, the parabola. Does it curve upwards or downwards? All right, so we know that that's implied. That implies a down curvature, downwards curvature. You can think of in that term, and it would look something like this. That's not too bad, especially since we knew that this was a +7. And oh, we didn't write the line of symmetry, so let's calculate that now. -7 plus 1 is -6, divided by 2 gives us a point of symmetry at x = -3. You can check that. There should be 4 units on each side of the line of symmetry to the x-intercepts. That looks about right. And the last one that I can label here is the point of symmetry to the y-intercept. What is this distance from here to here? It is 3 in the negative direction. Twice will give us a -6. The y value matches as 7. And the last thing we need to do is figure out the y coordinate for the vertex. We knew the x value corresponding to that is a -3. Let's do a little bit of algebra here on the side and show our work. Letter C. We know for this quadratic, the vertex happens when x = -3. I wanted to point out one more thing before I proceed with this vertex. If you're getting confused of how I'm getting the point of symmetry quickly in my head, check out the previous video, because it was shown many times in that video. Okay, I don't like where I labeled my point, so I'm gonna try and fix that. Should be corresponding to there. Perfect. That's a lot better. All right, so good. For this quadratic, vertex is when y = -3. So I'll show a little bit more work. Y = -1 times. When x is -3, be very careful. -3 minus 1 is -4. And on the second expression, -3 plus 7 is 4. So the y value becomes +16. Therefore, the point is -3, 16. And it should fit our picture perfectly. If it doesn't make sense, then we must have made a mistake somewhere, and try to go back and fix that. And notice how quickly and now very efficiently we're able to go from the graph, from the equation to its graph. All right, and think of that key question for the previous two and the next one. What is the most convenient thing to find in this format? Is it the x or the y-intercepts? In this format, again, because it's negative something times something, it is the x-intercepts. That's the most convenient thing to find. So let's start with that. Letter A, x-intercepts. What do we know about all the x-intercepts? It's when y = 0. Great, we've done that a bunch of times. So therefore, we know the points are going to be -12, 0. And the second point is 4, 0. All right. The y-intercept, a little bit more work to do. but we know the same idea that x equals 0 for all y-intercepts. And we're going to show a little bit more work there. This one we could do all in our heads because it's very convenient to find. All right, so y equals a -1. Again, I like to write the -1 because it's implied even though it's not, the integer is not shown. And when we plug in a 0, we get a 12. When we plug in a 0 to this one, we get a -4. So -1 times 12 times -4. In whatever order you simplify it, it becomes positive 48. So 0, 48. Check your work there. Be careful. Make sure you don't make any mistake with your symbols. That's crucial. It will not make sense in your graph if you make a mistake somewhere here. All right, let's start plotting points and drawing the picture. So we have 4, 0 somewhere right there, and then -12, 0 somewhere here. I also immediately notice the negative, which implies a negative something square. So think curving downwards. -12, 0. And we know the line of symmetry will be somewhere along here on this line, known as the axis of symmetry. All right, so then we know that the midpoint of -12 and 4 would be -8 divided by 2, which is x equals -4. That means there's 8 units to the right of each x-intercept from that line of symmetry. So if our vertex is somewhere up here at -4, some y value that we need to figure out, our picture will look something like this, however. Let's start with the picture. I don't know, something like that. There we go. I usually have an easier time doing these on paper, but oh well, there's my picture. And we know this point as well is 0.48. We know that this distance from here to here is 4. So 4 twice in the negative direction should have a symmetry point of -8, 48. And the last thing, like we said, do a little bit of work for the vertex. And that vertex, and for this particular quadratic, occurs when x equals -4. So I hope you notice how it changes for each quadratic. So -1 times, remember that we're keeping this -1. Plugging in a -4 here gives us 12. -4 plus 12 is -8. And then plugging in a -4 minus 4 gives us -8. So notice how this should be, oh, I made a mistake somewhere. There it is, -4 plus 12 is +8. There we go. So that makes sense now as +64. So this is -4, 64. And now it makes sense with my picture. I knew I had made a mistake earlier because the y value on the picture obviously should be some positive y value, and I had gotten a negative. So that's how I need to correct this one right here. Cool. There it is. And again, the most important thing that I want to point out about problems numbers 1 to 3, I'll write it in a different color to emphasize that. Numbers 1 to 3. What was the most convenient thing to find in those 3 forms? It was the X-intercept. So therefore, I'm going to refer to it as X-intercept form. Those are 3 examples of what I like to call X-intercept form. Unfortunately, the textbook don't use that term, or a lot of mathematicians that I know, they don't refer to that as X-intercept form. But I will do that for right now until we come up with our actual textbook names. And I call them X-intercept form because, look, it's really easy to find the X-intercept for this one, and for this one. We can do it. We did all of them in our head. And that looks some form of, it's not complete, but it looks something like y equals x minus the first X-intercept. I'm going to use subscript for that, times x minus the second X-intercept. All right, so think of it like x minus 7 or x plus 11. The minus doesn't mean that the number, the X-intercept has to be a negative. It's just the opposite symbol. If, like we said, if this is plus 12 the x-intercept is a negative 12. That's what that represents. So think of that idea. If it's a little too advanced, we're gonna revisit it later. Okay, but that was this is the most important point of this lesson. This is more like practice review from previous lessons, right? This is like the idea that we're focusing on, the concept rather than the math itself right now, although it is good to practice that. So if there's an X-intercept form, what do you think the other form is going to be? Let's ask ourselves that same question from before on question number 4. What is it most convenient to find in this format, the X-intercept or the Y-intercept? Well, now it's not the something times something form that we got before. Now it looks like it's the multiply form. So if you remember, if we plug in a 0 here, what's 0 squared? Is 0. What's 2 times 0? Is 0. So if we plug in a 0, all of these first two terms go away, and we're left with the Y-intercept. That's right. So for this one, I'm going to start with the Y-intercept. And we know that the X is equal to 0. And maybe I'll show it one time so you can see what I'm saying. That is when we have 0 squared, X squared, plus 2 times X, which is 0, minus 15. Remember that simply just becomes negative 15. But we're going to do this part in our head later, since it's very easy to visualize going to 0. But remember the point, we want to write it as 0, negative 15. All right. I'm writing this one out because I didn't really get a chance to write it in the previous video, but I will be skipping this work from now on. And the X-intercept is the one that requires more effort here. And the effort is factoring. So hopefully you're okay with your factoring practice. Otherwise, go and work on those videos now. X-intercept is when y equals 0. So I will try to write this in factored form in the something times something format that was given in the previous 3 problems. And we're thinking of two numbers that multiply to a negative 15 and combine to a positive 2. Can you think of those two numbers while I write this x times x? It is some form of 5 and 3. That's right, some form of 5 and 3. Because this is positive 2, we have positive 5 and negative 3. But the x-intercepts, I'm just going to write the answers now because like we did in the previous problems, it's very easy to figure out from here. And maybe I shouldn't group them that close together, but what's the first x-intercept? It is negative 5, 0. The order doesn't really matter. I'm just looking at them in the order that I wrote them. And what's the other x-intercept? It is 3, 0. As long as you're able to find those in whichever order you wrote them, that's correct. What matters is how we draw them in the picture. And there we go. We have 3 points just like we have done in other problems. Let's start putting those together, plotting some points. 3, 0, somewhere here. Negative 5, 0, somewhere right there. And line of symmetry should probably be somewhere here. Always visualize that when thinking about graphing these. Okay, great. And we know that is this positive something square or negative something square? It is positive something square, therefore it's going to curve upwards. All right. Probably going to redo that. It's okay. There we go. That's not too bad. You take this time to see if you can sketch these faster than I can and label all those points that we're comfortable doing. This one's got to be the 3, 0. This has got to be the negative 5, 0. We know that the line of symmetry happens when we find the midpoint of these two x-intercepts. That would be negative 5 plus 3 is a negative 2 divided by 2 is x equals negative 1. Check your work there. So this point must be negative 1, some y value. And I think we knew something else. There it is. It is the y-intercept, 0, negative 15. And the corresponding point of symmetry to the y-intercept, hopefully you can visualize it, is right there. It is negative 1 twice in the, or 2 in, I lost my train of thought, but there it is, negative 2, 15. Hopefully you can visualize that is what I was trying to say. Okay, great. Last thing is show a little bit of work. This is the most tedious part of the problem, in my opinion, and it is for the vertex. And when does that occur? When x equals negative 1 for this particular parabola, not for all of them. Don't forget that. And the question for this is, should I plug in my 1 to to the multiplied form or the factored form? The answer to that question is it doesn't matter, because we should get the same answer, but I always find that the easier work should be in the factored form. If you prefer to plug it in here, that's fine. I'm gonna go with the factored form. So y equals, when I plug in a -1 to this term, we get a 4. And -1 minus 3 is -4. So therefore the vertex is -1, comma, -16, and done. There it is. Keep thinking of what's convenient to find in this format. What's convenient to find in this format? Is it the X or the Y-intercept? It is the Y-intercept. All right, great. So see if we can speed up. In this format, it is the Y-intercept, and that is when X equals 0. That point is going to be, hopefully you can see, is 0, 5. That's why it's convenient. The answer is right there in front of us. It is 5. It is -15 here. The more difficult thing to find is the X-intercept. We have to show a little bit more work. That happens when Y equals 0. And therefore we have to factor this. 0 equals something times something. What is the factored form of this? It is going to be X minus 5 times X minus 1. Double check your work. That absolutely works. And we know that the points are 5, 0 and 1, 0. Great, we have 3 points already. And with that, we can find the line of symmetry. Let's see if we can do this faster than I can. 1, 0, 5, 0. Line of symmetry, somewhere right there. Is this positive something square or negative something square? It is positive, so therefore it does concave up. I'm curving up. Vertex is somewhere right there. We should see, visualize some kind of parabola like this. This is not too bad. I will keep that picture. That's good. Which one X-intercept is this one? It is the 5, 0. Here on the left, we have the 1, 0. The average of 5 and 1 is 3. So the vertex happens at 3. Check that there's 2 units of space on each side of the X-intercept from the line of symmetry. We also know a Y-intercept of 5. So 0, 5. And we can easily find its point of symmetry. It is 3 units to the right twice, therefore 6, 5. Look at how fast we're able to do this now. And the last thing we're missing is 3 commas, some Y value. How do we figure out the vertex, the Y value of the vertex? We know that happens at the line of symmetry. When X equals 3, therefore we can say the Y value is, again, I prefer the factored form. Plugging in a 3 to the first one gives us a -2. Plugging in a 3 to the second term gives us a 2. So the Y value is -4. The X coordinate is 3. And we are done. I'm thinking of ending the video right here, but I think it's already pretty long. But if we can apply the speed to the last one, I think we'll be in good shape. If you got to go, then think of a name that we are going to associate with this one, all right? Just like we did with the first 3. If you're curious, stay tuned. All right, so here's what I'm saying, especially because we see the negative something squared. So I do want you to think about those kind of problems. But still, what's easier to find in this format, the X or Y-intercept? It doesn't change. Negative something squared is still a 0. So for that reason, we're going to still begin with Y-intercept. That happens when X equals 0, and the Y-intercept is right there in front of us. It is a +24. Done. Look how quickly we did that. That can give you a hint as to what we're going to refer to these format, this type of form of equations as, right? And X-intercept requires more work, especially now that it has a negative. We have to factor out even more that negative. So I'm going to factor out a negative from this one. If you're a little confused, revisit the last video. We spent more time on those. I'm going to say that this is negative something squared. I'm just going to take the opposite symbol of all of these. What's the opposite of this one? It is +x squared. What's the opposite of -10x? It is +10x. What's the opposite of +24? It is -24. All right. There it is, rewritten. And the reason for that is now we can think of what's the factored form of what's inside the parentheses. The negative will remain outside. So y equals a negative something times something. Now let's go ahead and factor that. What two numbers can multiply to a negative 24 and combine to a positive 10? It better, and again, I should make this a 0 at this point. It is a positive 12 and a negative 2. Check your work. That absolutely works. Therefore, the x-intercepts are negative 12, comma 0, 2, comma 0. So with a little bit more work and an extra step, we were still able to do that. Remember, it's a graph that curves down. So when we start making our picture, let's keep that in mind. Negative 12 and 2, line of symmetry, somewhere in the middle of those two. And this better be the 2, comma 0. This one, the negative 12. All right. And because it's negative something squared, it has to be a type of graph that curves downwards. Something like this. That's a pretty decent looking parabola. We know this point is 0, 24. Everything is fitting perfectly in our picture. Therefore, the matching point, we need to matching symmetric point. We need to figure out that line of symmetry, and it also will help us for vertex. Vertex when x equals some y value, the midpoint of negative 12 and 2. Let's do that now, which is negative 5. So when x is negative 5, we will have that. All right, and also our vertex. All right, let's do vertex and we'll first, and then we'll find the point of symmetry later. So you can see the order doesn't really matter in which we do this. I again prefer the factored form, and it is this one right here. So it's going to be negative something times something. When we plug in this negative 5 to the first term, be careful with the symbols, we get a positive 7. When we plug in a negative 5 to the second factored term, we get a negative 7. And the point becomes negative 5, comma 49. Notice that it fits our picture perfectly. Negative 5 should have a positive y value at its vertex for the y value, okay? And the last thing is that point of symmetry. We have 5 units 2 times in the negative direction, gives us a x value. Let me draw that a little bit better. I know it's somewhere right there, of negative 10. And the matching y value is 24. That one doesn't change. All right, that's all of the practice. I know that this, even though we spent a little bit of time showing work, what I want to emphasize the most is the last 3 problems. I'm going to call them, again, put in yellow to emphasize that this is important. What was the most convenient thing to find in numbers 3 all the way to 6? It was which intercept? The y-intercept. Every time the y-intercept was the easier one. Look, the y-intercept was right there in front of us. The y-intercept was negative 15. The y-intercept is 24 right in front of us. So therefore, these 3 are examples of what I refer to as Y-intercept form. And why do I call them that? Because the y-intercept is the most convenient thing to find in that format. Later, we will give it a textbook name. But for right now, we will say that this is y equals, I don't know, in this basic form is x squared plus some number b, think of this like 7x or minus 4x or minus 2x or minus x or plus 11x. And then plus some letter c, like minus 24 or 16. There should be an a term right there. We will talk about that later. But for the ones we're being using right now, it looks more of this format, all right? So if you want to add that a term right now, that's okay. That's perfectly fine. Because we've been using 1 and negative 1 as our a term in the last few anyway. So just to clean that up, this is the end of this practice. And just to talk about these ideas of X-intercept form and Y-intercept form was the main new thing to discuss here. All right, guys, stay tuned for some more. See you on the next few videos. Bye.